Hello everyone. In this video, I will be discussing about extract min operation in heap data structure. In my previous video, I've already explained like what is heapify operation. So we know that heapify means like in the heap there will be a node which is violating the property. Either it can be min heap property or it can be max heap property. In order to restore the heap property, we need to perform heapify operation on that disturbing or on that violating node. Now for extracting minimum in min heap, like I have taken an example. So this is a min heap where the root will be the smallest. Okay, the root node will be having the smallest value. So suppose before performing extract min, like I need to perform get minimum. So in order to get the minimum from the heap, like we will be passing array because we are representing this heap in array form. Okay, so in order to get the minimum, the output will be like the first element of the array. Okay, always the first element of the array, because we know that min heap is having the smallest node value in its root. Okay, and that we need to return. So using get min, we will be having the minimum value in the min heap, which will be nothing but the first value in this array. Now the next operation is extract min. So in case of extract min, like what we need to do is that we need to find the minimum and then we need to extract it from the heap. Okay, we need to extract it, we need to remove it from the heap. Okay, so this heap is represented in the form of an array and we need to extract the minimum. So we know that minimum will always be in the root node and in the array it will be in zero index location. So for performing extract min operation, the first step is to swap the value, that is the first value and the last value. Okay, we need to swap the first value and the last value. So after swapping the first value and the last value, we'll be having our array, that is 8, 4, 6, 7 and 2. This will be the array which we will be having after swapping the first value and the last value. And after that we need to decrease the size of this array. Initially the size was 5. Now we'll be reducing the value, we'll be reducing the size value. So now the array size will be 4, like from 0 to 3. So we will ignore this index. Okay, because the main thing is that we need to extract minimum from the heap. So first we need to get the minimum, and we got the minimum from the first index value. Then after that we need to swap it, we need to swap this value with the last value. Okay, and after swapping the value we need to decrease the size. So this is the first step. And why we are decreasing the size? We are decreasing the size because we want to remove this 2 from the heap. Okay, and we know that heap is represented in the form of an array. So this complete heap is represented in this form. So if I'm going to decrease the size by 1, it means that now only this element will be there in the heap. Okay, so by reducing the size, it means that I am removing this element. Okay, so after this the tree will be like, if we look at the tree, like we have swapped this 2 from 8. So 8 will be over here and 2 will be here, and we are ignoring this 2 by decreasing the size. So we are ignoring this 2. So our heap will be like this: 8, 4, 6 and 7, and we have ignored this 2. In the array we have decreased the size, and in the heap we have removed this 2. Now if we look at this heap, we find that the min heap property gets violated. And why it gets violated? Because of this value, because of 8. Okay, the left subtree is the heap, the min heap. The right subtree is also the min heap, but because of this single node, the whole heap is violated and it does not follow the min heap property. So what we can do, we already know that if a node is violating the min heap property or max heap property, we need to perform heapify. We need to perform heapify on this node, on this violating node. Okay. So heapify operation is done on that node whose left subtree and the right subtree are obeying the property, but this node is violating the whole heap. So we'll be performing heapify, and after performing heapify, like suppose this is 8, 4, 7 and 6. So in heapify we know that like we need to compare 8 with 4 and 6, and we need to move towards smaller direction. So already in my previous video I have explained the code of heapify. So the minimum is 4. So the minimum is 4, we need to swap this value 4 with 8. Now 4 will over here and 8 will be over here. Now again, because of this node the min heap property gets violated. So we need to perform min heapify again on this node. So we need to compare 8 with its left child and the right child, and we need to move towards smaller direction. So the smaller direction is this. So 7 will be over here and 8 will be over here. So we'll be swapping the values in the smaller direction. Okay, so the new heap will be like 4 will be on the top, here 7, 6 and 8. So if we see, we find that the value 2, the value 2 uh, has been removed from the heap. Like we have extracted the minimum value, and after removing 2 we have got this modified heap. So there are two steps which we need to take care of. Like first we need to swap the starting index value with the last index value, and after swapping we need to decrease the size, and after that we need to perform heapify operation on the root node. On performing heapify operation on the root node, we will be restoring the min heap property, and the minimum value will be extracted from the heap. So this is all about extract min. Similarly, in case of extract max, we need to swap the values and then we need to perform max heapify. Okay. So depending on the type of heap, like we can perform min heapify as well as max heapify. But as this heap is a min heap, so for restoring this, we need to perform min heapify, and if this is the max heap, in that case we need to perform max heapify. Okay, so min heap and max heap will have the same operation but in opposite manner.